The objective of this last section is to describe other types of bulk and non-bulk containers and their associated hazards. Not every type of container that a first responder will encounter can be classified according to the previous mentioned systems. Additional types of bulk and non-bulk containers include radioactive material containers, pipelines, intermediate bulk containers, and non-bulk containers. All shipments of radioactive materials, sometimes called RAM, must be packaged and transported according to strict regulations. These regulations protect the public, transportation workers, and the environment from potential exposure to radiation. The type of packaging used to transport radioactive materials is determined by the activity, type, and form of the materials to be shipped. Depending upon these factors, radioactive material is shipped in one of the following 5 basic types of containers listed in order of increasing level of radioactive hazard. Accepted packaging is used to transport materials that have limited radioactivity, such as articles manufactured from natural or depleted uranium. Accepted packaging are only used to transport materials with low levels of radioactivity that present no risk to the public or environment. Empty packaging is accepted. Accepted packaging is not marked or labeled as such. Because of its low risk, accepted packaging is exempt from several labeling and documentation requirements. The second is industrial. These containers designed, retain, and protects its contents during normal transportation activities. Industrial packaging are not identified as such on the package or shipping papers. Industrial packages contain materials that present a limited hazard to the public and the environment. Examples of these materials include slightly contaminated clothing, laboratory samples, and smoke detectors. The next is Type A. This container design protects its contents and maintains sufficient shielding under conditions normally encountered during transportation. These packages must demonstrate their ability to withstand a series of tests without releasing their contents. The package and shipping papers will have the words Type A on them. Radioactive materials with relatively high specific activity levels are shipped in Type A packages. Examples of these materials include radiopharmaceuticals, which are radioactive materials for medical use, and certain regulatory qualified industrial products. The fourth is Type B. These packages must not only demonstrate their ability to withstand tests simulating normal transportation conditions, but they must also withstand severe accident conditions without releasing their contents. Type B packages are identified as such on the packaging itself as well as on the shipping papers. The size of these packages range from small containers to those weighing over 100 tons. These large, heavy packages provide shielding against radiation. Radioactive materials that exceed the limits of Type A packaging requirements must be shipped in Type B packages. Examples of these materials include materials that would present a radiation hazard to the public or the environment if they were a major release, and the materials with high levels of radioactivity, such as spent fuel from nuclear power plants. And last is Type C. These are rare packages used for highly activity materials, including plutonium, that are transported by aircraft. They are designed to withstand severe accident conditions associated with air transport without loss of containment or significant increase in external radiation levels. The Type C package performance requirements are significantly more stringent than those for Type B packaging. With pipelines and piping, according to PHMSA, as of the year 2015, there were over 2.5 million miles of pipelines in North America. These pipelines transport a variety of flammable and non-flammable hazardous gases and liquids, including natural gas, propane, hydrogen, crude oil, diesel, gasoline, jet fuel, home heating oils, carbon dioxide, and anhydrous ammonia. Pipelines are usually buried, but they may be located above ground as well, especially in cold climates where the ground is often frozen. In some cases, multiple products may be pushed through the same pipeline at the same time or separated by a pipeline pig. Hydrocarbons are often commingled. Pipelines also carry a variety of sizes and pressures depending on the product and the function of the line. For example, large natural gas transmission pipelines operate under extreme pressure, while smaller distribution lines typically operate under much lower pressures. Pipeline breaches can be caused by excavation, corrosion, equipment, material joint or weld failures, operation errors, natural disasters such as earthquakes and floods, or vehicle collisions. Emergency responders can view the transmission pipeline in their area via the National Pipeline Mapping System available online. This system does not provide data on gathering and distribution lines. Pipeline releases can be violent, particularly if gases and/or high-pressure transmission lines are involved. Spills and leaks can involve large quantities of product. Since most products transported by pipelines are flammable or combustible, fire control should always be a priority consideration in pipeline incidents. Some indications of pipeline leaks and ruptures include visible vapor clouds or liquid spills, hissing, roaring, or explosive sounds. Strong odors such as rotten eggs or petroleum smells, liquids bubbling up from the water or soil with no obvious source, high pressure gas blowing out of the water or soil, and dead vegetation or discolored snow above a pipeline right-of-way. Pipeline markers in the U.S. and Canada include the signal words caution, warning, or danger, representing an increased level of hazard. They also contain information describing the transported commodity, carrier operator's name, and an emergency telephone number. Establishing good communications and cooperation with the pipeline operators before an emergency occurs is an important element of emergency response preparedness. Pipeline operators are required to provide a wealth of information to emergency responders that can help reduce the impact of an actual release, including location of transmission pipelines that cross their area, name of the pipeline operator and emergency contact information, products carried and their hazards, location of pipeline emergency response plans, how to contact the pipeline operators regarding questions, concerns, or emergencies, and how to safely respond to a pipeline emergency. You can find general consideration for responding to a pipeline emergencies on pages 22 through 25 of the 2016 Emergency Response Guidebook. Many industrial, commercial, and industrial facilities have piping carrying everything from water and steam to hazardous materials. Pipes carrying hazardous materials should be appropriately marked and labeled. Many facilities in the U.S. and Canada follow ANSI's A13.1-1981 scheme for identification of piping systems to mark and label pipes. Per the U.S. DOT, an immediate bulk container, IBC, is either rigid or flexible, portable packaging other than a cylinder or portable tank, designed for mechanical handling. Design standards for IBCs in the U.S. are based on United Nations recommendations on the transportation of dangerous goods. The maximum capacity of an IBC is not more than 3 meters cubed. The minimum capacity is not less than 0.45 meters cubed, or a maximum net mass of not less than 882 pounds. IBCs are authorized to transport a wide variety of materials and hazard classes, including aviation fuel, gasoline, hydrochloric acid, methanol, toluene, corrosive liquids, and solid materials in powder, flakes, or granular forms. IBCs are divided into two types: flexible intermediate bulk containers and rigid intermediate bulk containers. Both types are often called totes. FIBCs are sometimes called bulk bags, bulk sacks, super sacks, big bags, or tote bags. They are flexible, collapsible bags or sacks that are used to carry both solid materials and fluids. The design of the FBICs are as variable as the products they carry. Often the bags used to transport wet or hazard materials are lined with a polypropylene or some other high-strength fabric. Others may be constructed of multi-wall paper or other textiles. A common-sized super sack can carry the equivalent of 4 to 5 55-gallon drums, and depending on design and the material inside, can be stacked one on top of another. Sometimes FIBCs are transported inside a rigid exterior container made of corrugated board or wood. Rigid intermediate bulk containers are typically made of steel, aluminum, wood fiberboard, plastic, and often designed to be stacked. RBICs can contain both solid materials and liquids. Some liquid containers may look like smaller versions of intermodal non-pressure tanks with metal or plastic tanks inside rectangular box frames. Other RIBCs may be large, square, or rectangular boxes or bins. Rigid portable tanks may be used to carry liquids, fertilizers, solvents, and other chemicals that may have capacities up to 400 gallons and pressures up to 100 psi. Non-bulk packaging containers are used to transport smaller quantities of hazardous materials than using bulk or IBCs. They are usually used during highway transport or other routine transportation. Non-bulk packaging includes the following types of containers: bags, carboys, and jerry cans, cylinders, drums, and dewars, flasks, which hold cryogenic liquids. Let's talk about bags. A bag is a flexible packaging made of paper, plastic, film, textiles, woven materials, or other similar materials. Bags may transport explosives, flammable solids, oxidizers, organic peroxides, fertilizers, pesticides, and other regulated materials. They can be sealed in a variety of ways, including ties, stitching, gluing, heat sealing, and crimping with metal. Typical bags are stored and transported on pallets. A carboy is a large glass or plastic bottle encased in a basket or box, primarily used to store and transport corrosive liquids, although its use has expanded to non-hazardous materials such as water as well. The other packaging may be made of such materials as polystyrene or wood, and carboys may be round or rectangular. Their capacities may exceed 20 gallons, but 5-gallon containers are more common. Jerry cans is another name of a rectangular plastic carboy and is the term used in UN regulations. Some organizations differentiate between carboys and jerry cans, defining such jerry can as a rectangular metal container typically transporting flammables and combustible liquids, and carboys as transporting corrosives. Cylinders is a pressure vessel designed for pressure higher than 40 psi and has a circular cross section, but it does not include any of the containers, tanks, or vessels described in previous sections. Cylinders are used to store, transport, and disperse large volumes of gaseous materials. Compressed gas cylinders range in size from small lecture bottles, small bottles used for classroom demonstrations, to large cylinders and have varying pressures. All approved cylinders, with the exception of some that store poisons, are equipped with safety relief devices. These devices may be spring-loaded valves that reclose after operation, heat-fusible plugs, or pressure-activated bursting discs that completely empty the container. All fittings and threads are standardized according to the material stored in the cylinder. As yet, there is no nationally regulated color code that permits visible identification of cylinder materials or by color. Some manufacturers use a single color for all their cylinders, while other manufacturers have their own color coding system. All local manufacturers and distributors use an identification system. it should be identified in emergency response plans. A drum is a flat-ended or convex-ended cylindrical packaging made of the following materials: metal, fiberboard, plastic, plywood, or other suitable materials. Drum capacities range up to 119 gallons, but 55-gallon drums are the most common. Drums may contain a wide variety of hazardous and non-hazardous material in both liquid and solid form. Typically, metal drums carry flammables and solvents, and plastic poly drums carry corrosives. Drums have the following two types of tops. Open head is where the top is removable, and the tight or closed head is where the top is non-removable and has small openings plugged by bungs, which are stoppers. A Duraflask or vacuum flask is a non-pressurized insulated container that has a vacuum space between the outer shell and the inner vessel. The Duraflask is designed for the storage and dispensing of cryogenic materials such as liquid nitrogen, liquid oxygen, and helium. Durs have a bulky appearance due to the insulation used to keep the cryogenic at the desired temperature. The volume of a Duraflask is often between 4 gallon to 125 gallons. Some Duraflask may be as large as 1,250 gallons. The review question for this last section is to list other types of containers that first responders may encounter and what kinds of hazardous materials they may carry. To find the answers for these questions, look in the manual on pages 272 through 283. The only skill for this chapter is to analyze a hazardous material scenario to identify potential hazards. In summary, we've described methods of identifying potential outcomes. We have explained the role of general hazardous material behavior model in predicting the behavior of containers. We have recognized general container types and their associated behaviors. We have described the types of bulk facility storage tanks and their associated hazards. We've described the types of cargo tank trucks and their associated hazards. We have described the types of tank cars and their associated hazards. We have described the types of intermodal tanks and their associated hazards, and have described types of bulk transportation containers and their associated hazards. And the last is we described other types of bulk and non-bulk containers and their associated hazards. That concludes Chapter 5.